Let's use this idea of closure to write an iterator function, and what we would like to do is that it should give us a new number starting from a particular number, increasing by some fixed step size every time we call that function. And we don't want any upper cap. That is, as long as we call the function, we keep getting numbers in a step. For example, we may say that we would like to start from the number 0 and keep getting numbers in steps of 2, which will be all the even numbers. Okay. Now I want you to pause the video here and try it yourself before moving on. It is okay to struggle a little because that's how you really learn. So let me write this function and call it a step iterator, which takes two arguments from the user, the starting number and the step size. Inside this, we write another function, and we can just write an anonymous function because we can return right from here. Okay. Make sure that you understand this. All we are doing is returning this function from the step iterator function. Now let's write the body of the nested function. So first we hold the value of start in another variable. Let's call it res for result. Now we change the value of start by adding step to it. Alright. And then we just return the old value of start held in res. Let's call this function step iterator, but because it returns a function, we will need to invoke it later. So let's hold it in a variable. Let's call the variable numbers with 2 steps. And this should be equal to step iterator with the start value of 0 and step size of 2. Okay. So now this variable holds a function. And now we can use this variable to call the function. And we keep getting new numbers as many times as we call this function. Alright. Now this is happening because the start and step variables had a local context and were used inside the inner function, which keeps updating the value of the start variable. So every time we call this function, we keep getting the new values of the start variable, which also gets updated in each call. Also note that if we call the step iterator again, even with the same arguments 0 and 2, and held it in another variable, let's call it another, calls using another will start the iteration from 0 again, and it will not conflict with the previously created iterator. So both of them can happily go their ways.